In this figure, we are given a circle, and inside this circle is a triangle inscribed. Here it's given that BC is the diameter of the circle, and BC's length is given as 132. And the length of AB is given as under root 363. We have to find the value of BC upon BD, and it's also given that this is right angle. So the main problem is that this is not breaking it into two equal parts. This is a scalene triangle. What we can do is we can either use similarity or trigonometry to solve this question. Those will be the two easiest way. So we are going to solve it by similarity. For that, we need two similar triangles. If we want to prove two triangles similar to each other, that is, if we want triangle ABC is similar to triangle PQR, what we want is, we want two angles to be equal. Any two angles. If we can figure out any two angles that are equal, then this triangle is similar. And once it's similar, then what happens is the ratio of the corresponding sides are equal. That will be AB upon PQ will be equal to BC upon QR. That will be equal to AC upon PR. Then the respective corresponding sides ratio will be equal. That's what we are going to use here. So for getting any two angles equal, it's actually very simple. This angle, you can take it as theta. This angle is right angle. Now you should know that BC is the diameter. So it will subtend a right angle here. This angle is going to be 90 degree because diameter always subtends right angle. So this angle is 90 degree. Now we have the similarity down. Basically, triangle ABD is similar to triangle ABC. Reason? By angle. Because it has two angles equal. Which two angles equal? Both of them has an angle theta and both of them have right angle. Here angle BDA is 90 degree and here angle BAC is 90 degree. But we are going to figure out the other angles also because we need them for corresponding angles. This is theta, this is 90. Sum of all the angles in a triangle is 180 degree. So this one is going to be 90 minus theta. Now this is 90 degree, this is 90 minus theta. So this angle is going to be 90 minus 90 and minus into minus plus theta. So this is basically theta. Same result here also in this triangle. This is theta, this is 90. So this is going to be 90 minus theta. And I'm going to shade the two triangles that we need. First is this triangle. We are using this. And then we are using this whole big triangle. Now, the corresponding sides ratio is equal. So let's take a side AB from the small triangle and a side BD from the small triangle. Now we'll see the angle opposite to them, AB. In this triangle, AB has 90 degree opposite to it. So the corresponding side in the bigger triangle will be whatever side is opposite to 90 here, that is BC. The whole triangle we are taking, so we'll take the whole side BC. Upon BD. BD in this triangle, it's opposite to 90 minus theta. In this bigger triangle, opposite to 90 minus theta, what side we have? AB. And remember, we are taking the triangle ABC. So we can only take the sides of ABC. We can't take AD. So opposite to 90 minus theta in this triangle, we have AB. We'll cross multiply it. So AB square is equal to BD into BC. So by that we can get AB square, that is 363 is equals to BD into BC. Now BD is equal to, that's what we have to find. And BC is equal to 132. So we can break it here. BD will be 363 upon 132. If you want, you can divide it here or we can divide it in the other step. We need the ratio. We don't exactly need the value of BD. We just need the ratio of these sides. So for this, BC upon BD. It will be equal to BC is 132 upon BD, that is 363 divided by 132. So this will be multiplied here. Now we'll start cancelling this out. Now 132 and 363 can be divided by 11. This will go 12 times. This will go 33 times. Now this 132 can again be divided by 11. This will again go 12 times. This will go 3 times. And this is cancelled 4 times. So the value we are getting is 4 into 12, that is 48. So this is the answer. The ratio of BC upon BD we have to figure out. So it's coming as 48. This is the ratio. And please remember to do this also.